next presentation will be Ms. Soma Pandey. She is the General Manager for IoT Devices in the Reliance Jio Infocomm. Talking more about Ms. Pandey, Soma Pandey graduated from NIT Bhopal in Computer Science and Technology, and presently she is working as a General Manager at Jio Platform Limited in IoT Device Engineering. She is an IEEE member for the last 13 years and was elevated to senior member in the year 2016. She has many international publications and served as a TPC for many international conferences. She has served in a Exicom on the IEEE Bangalore section and also the IEEE Women in Engineering and in IEEE Communication Society. Her core area of interest are wireless LAN and PAN networks, IoT communication protocols, wireless sensor engineering, IoT platforms, and the LTE network. Her doctoral research are being the area of wireless and mesh networks. So from processor, now we are going to a different visionary talk where we will talk about the networks, connectivity, and this is our together we'll look at the future that connectivity and processing comes together and solve our real life problem. So over to you, Soma.
Hello, thanks, Sumit. I hope, am I visible?
Yes, Soma, you are visible.
Yeah. Thanks for such a nice introduction and good morning. Welcome all to IESA Vision Summit, and very nice to be given. I'm thankful to be given this opportunity to present the perspective of a telecom from the for IoT. So my main talk will be mainly focused on this aspect. So I will walk you through a series of a presentation in which I have tried to present the IoT from how a telecom looks at this domain. So as we all know that now the future is going to be more and more connected, and recently in this time of pandemic we have seen how wonderfully connected devices have made things like easily and smoothly helped us wade across all this the difficult times of pandemic, like whether you talk about this present conference that we are conducting virtually, or we talk about the virtual payments, so home deliveries. So definitely there is now IoT has even more bigger role to play, and we look forward to a brighter and better future with the help of connected devices. So let me begin my presentation. I'll turn off my video so that the connectivity is better. I'll just turn off the video and I'll just share my screen. So this is a presentation where I just want to remind every one of you, you must be remembering this estimate, which was a very famous estimate by many corporates, including to name one is Ericsson, who had estimated that in 2020 we will be having 50 billion connected devices. So now let us just see that what is the present scenario. So in 2018, so this projection was given in 2016. So let us see where we are in 2018. We were having 7 billion IoT devices, which moved over in 2019 to 26 billion. And we are adding 127 new IoT devices every second, which is a big number. And there's an estimate that by 2020, we may be having around 31 billion IoT devices. And in 2021, this number may move to 35 billion, and 2025 75 billion. So I hope let us see that whether we will be actually there or not, that we can meet and discuss again in the Vision Summit 2025. As of now, of course, it's not 50 billion as it was predicted, but very close to it. 30 billion is also close enough, and it's a huge number, let me tell you. And based on the popular tweet words and through artificial intelligence, especially from Twitter and LinkedIn, the use cases which have been listed in the top 10 order, you can see that the highest use case over here is residential IoT, and the next one followed very closely followed by wearables, then smart city, smart grid. So actually smart city covers a lot of use cases, not only smart parking and waste management, but even now the smart connectivity with the buses and the metros and locals, all being very well connected through IoT and sensors. So these are some top use cases which we will be seeing more of in the IoT domain. There is one use case which is missed out here. I feel that which is also should be one of the top use case, which is the surveillance. So because as of now, even if I have a smart home or a smart campus, camera is a very integral part of it, and right from a small grocery shop to a huge campus, everywhere cameras are there everywhere, and I feel that they are an important part of society now. This is a generic IoT solution high-level architecture, which all of us are very well clear about it now. Like we see that on one end there's the application. Application can be a web application or a mobile-based application or even a admin dashboard. So one end there is application, and on the other end you have the very power constraint small lightweight devices which are sensors, and the sensors might be which you can see over here. These are the sensors which might or might not be connected through a slightly more capable, more intelligent, more power rich device which we call as gateway. And then finally in between here we have the service capabilities, and this service capability is very important to take care of, and we call it as M2M core. So this is a standard high-level architecture as given by ETSI, which is a telecom standard, Europe Telecom Standard Authority, and has been adopted by most of the telecom standard organizations the world over. And if you see, this is the architecture which I was talking about. Then you have the sensors over here, then you have the internet gateways and hubs and some kind of data acquisition system. And this data acquisition system between the sensors and the gateways can be wired or wireless based on the kind of connectivity and the reliability, the two things which are very important. So whether you connect to sensor through a wired connectivity or wireless is mostly dominated by two things. One is practicability of the connectivity. Like for example, you cannot give a wired connection or you cannot run wires to a door sensors, say for example, and you cannot run wires all through your door, especially if they are glass doors. So there is one thing which is the aesthetics and the practicality of the sensor. Second part is the the connectivity of the sensor, how much robust it is, because we know that wireless connections may not be as robust or reliable as the wired connection. So these are the things which dominate the connectivity part. Then when we talk about the edge part, which is the IP side, then we have edge analytics, pre-processing, which is connected to a data center or a cloud part. So talking about cloud, we'll move to the IoT platforms. And as you can see, we used to have initially MQTT is the language which was we can call IBM as one of the major core contributors and inventors of MQTT. So MQTT played a huge role in doing that shift from heavyweight to a lightweight communication protocol. And MQTT as of now is the most popular protocol to connect the hub or the edge devices to the cloud. And this MQTT broker was the first generation of IoT platform, which was then further improved to a second generation, which also gave a device side, some kind of device side SDK firmware. Then it was followed by a third generation, which was not having an SDK or a firmware, but also had a web application enablement and also an Android app. Finally, we have the fourth generation and even a fifth generation. The fourth generation has the capability to, you can port multiple IoT application on a single window, which I am going to explain little more in my next slide. And the fifth generation is now focusing on standardization of these IoT platforms. And in this standardization of IoT platforms, 1M2M has played a major role. And 1M2M standard is a standard which is now most of the IoT platform people are trying to adapt to IoT 1M2M standard, or trying to keep their platforms as close to the 1M2M standard as possible. This is the difference between a horizontal IoT platform and a vertical IoT platform. So if you see, the vertical IoT platforms are just like silos, and definitely a smart home use case cannot access details from a smart weather IoT platform. And this may become a disadvantage, because you can see that a smart city may require at some point of time some data from smart home, or because of course the city is made of homes, so a smart city may require some data from homes. Likewise, even the smart home may require some data from smart weather. Why not? Because if it is going to be a rain and you have left your clothes hanging outside, definitely you will require to have a connect with the smart weather app. So how do you go about it? So the solution is going for a horizontal IoT platform. Now, why am I talking about horizontal IoT platform? Because from a telecom perspective, a horizontal approach will always be better than a vertical approach. Why? Because I, as a telecom service company, will not be concerned about the siloed environment, but I'll be trying to provide my platform to be as much useful as possible. The smart city and the smart home, they can collaborate with each other if I have a horizontal platform in between. So this is the difference between the two. And now 1M2M standard focuses on standardization of the horizontal IoT platform. Now these are the list of some very common and popular IoT platforms. We have Microsoft Azure IoT. They are also our partner now with Geo platforms, and your Amazon Web Services, Google Cloud, ThingWorks. Of lately, very recent additions, Bosch IoT is also there, and G predicts targets at going for industrial IoT connectivity more than a generic IoT approach. So these are some top IoT platforms. And when we next from cloud, we move to the connectivity side. So from northbound, we are moving towards the southbound. So the cloud has to be, or the IoT platforms have to be connected to the edge and to the hub, and finally to the sensor. So when we see over here, in the connectivity part, we are more focused, because we being an LTE service providers, we will just talk briefly about what all is there in the 3GPP standardization. And we all know that 3GPP has been formed by, it's not anymore a 7-country alliance, and it has a longer list now. And the first time LTE was introduced in release 9 by 3GPP, which went on to become LTE advanced. And release 12 and 13 were the releases which first time included IoT enhancements for 4G in the form of NB-IoT and LTE-M. Then we move over to release 15, which was the first time introduction for 5G new radio. And the latest one, release 17, is available at 3gpp.org, and people can go over there and have a look at it. From India side, as I have told, that the telecom various standards societies from different countries are a part of 3GPP. And from India, the TSDSI is the one which represents India in 3GPP. Telecom Standard Development Society of India, of which Geo is also a member. And just to give a broad overview for all of you to present the difference between what is an LTE-M and NB-IoT. And you can see that there is not much difference between the two. except for the thing that the maximum throughput in case of LTEM is 360 kbps and NB-IoT is just 30 to 60 kbps. And definitely for sensors, we are looking for a lesser throughput, because if you notice over here, the less throughput, high throughput comes at a cost of the range. Here the throughput is less, but of course range is very high. So this is the major difference between the two. And both can support a deployment density of around 50,000 devices per cell, which is pretty much good enough as of now, and we will be able to accommodate. So presently we haven't reached this upper limit of 50,000 per cell. So I think it's a good number, and it will take some time to get this saturation value. So we can say safely that LTM and NB-IoT will be here for a while. Okay, next I'll just give you a rough idea about how 5G and IoT are connected. So 5G has a 3-point agenda, and you must have this, a lot of people would have presented earlier also, just brush through. So you know that ultra reliable low latency, in which it targets to have less than 10 milliseconds of latency. And in case of 4G presently, so just wanted to compare it with the present scenario. So in 4G, the latency as of now is 30 milliseconds. So we will require to reach this 10 millisecond latency. The next target is enhanced mobile broadband. So the bandwidth of 5G network will be more than 1 Gbps is what is the estimated bandwidth, projected bandwidth 5G, with a minimum speed of 200 Mbps, which is huge. Now let me compare it with 4G. So as of now with 4G, it is 200 Mbps maximum, and the speed is 25 with speed of 25 Mbps. So this is the regular speed that we are getting with 4G. We can reach a maximum speed of 200 Mbps, but present speed is 25. So we require in the vision for enhanced mobile broadband, and we should have very high bandwidth, and we should have widespread coverage. The third point is that massive machine type communication. So in massive machine type communication, we have to support millions of devices per square kilometer. And just in the past slide, I have just compared and told that around 50,000 devices can be supported. So if we go with a normal, regular, non-NB-IoT, non-LTE 4G, normal 4G can support not more than 4,000 devices per cell. So if we have to increase the number, definitely we have to go for the other option. So that is the target of massive machine type communication. So the increase in number of devices, let me remind you, is coming at a cost of low data rate. So you won't be getting a very great speed if you go for NB-IoT or LTM. But yes, you will be able to connect larger and far more number of sensors to it. So from platform to connectivity, and let us move to the sensor. Now, what do we have about sensors? So I will just give you both. So both the ideas. So we have, if I don't know how many of you have actually connected your devices through Wi-Fi connectivity or having smart home devices, but the present scenario, when you purchase a smart device, like I'll give you an example. You have a smart air purifier. Then what do? So that smart air purifier is Wi-Fi enabled smart air purifier, which will keep giving you the details about the air conditions in your home in your mobile app. So the manufacturer is going to provide you a air purifier, and he's going to provide you an app. Then you will be told a procedure in which you will be which will be defined to allow your smart device to connect to your Wi-Fi router, whichever it is, irrespective of the service operator. So your your connectivity or your broadband operator may be any XYZ person, but he will allow your device from some another vendor to connect to the device manufacturer's platform. So this kind of models we call as hubless models. Now, where do the hubless models work? So this is important. So many times we get confused. When do we go for a hub-based model? When do we go for a hubless model? So always remember that a Wi-Fi enabled device is an IP based device and can always go for a hubless model where you can have a virtual hub sitting in the cloud somewhere and you don't require to have a specific vendor dependency. So it is more open solution in that sense. It is not a proprietary one. You don't have to depend on a particular vendor to connect your smart device to the cloud, and that is preferable in most of the cases because it is just a plug and play thing. But then there are many solutions where you may not be able to achieve it, especially in case of those connectivities where you go for non-IP kind of PAN networks. Like for example, there is Zigbee, there is BLE. Supposing you have a Zigbee based or a BLE based sensor, then that sensor cannot connect to your broadband router. Definitely you will require an intermediate hub or a gateway, which we call in between. Then in that case you may have to have a dependency on the service provider. But if you go for some kind of standardized solution, then it may not be required. Like for example, you can buy your Zigbee gateway or Zigbee hub from another vendor and a Zigbee sensor from another vendor, as long as they follow a Zigbee standard 3.0, which is the latest standard, or a BLE sensor, which is BLE 5 is the latest, and most of the times the standards are such that they are backward compatible. So a BLE 5 sensor may be comfortable working with a BLE 4.2 hub, or a BLE 5 hub may be easily connecting to a BLE 4.2 sensor. It must happen that way. This is all the things that has to be ensured by a solution architect or the engineering person. So this is about the hub based and the hubless models. Now I'll just give you a brief that what is the requirement for the end node. So the main requirements for end node, as accepted by most of the standards authority, is that the end node should not cost more than $4. So your motion sensor, your door sensor, smoke sensor, gas leak sensor, all those sensors should not be more than $5, which is really pretty very hard to achieve. Like we struggle day through night, and in Jio we really have this motto of being providing very economical and user affordable solutions, and plus with a good quality, which is very hard. It is a trade-off actually. When you go for a good quality, the cost may become difficult to manage. If you go for a good costing, then the other thing gets affected. So very difficult, and that is the toughest part of engineering a device or a sensor. Plus it should have more than 5 years of battery, and yes, so power saving mode and extended discontinued reception, these things are also added in a part of NB-IoT like LTEM services, wherein you can conserve the battery for longer time if your sensor is connecting through an NB-IoT connectivity. Next, I will just explain a bit about the SIM part. So as I told you that the device may be connected through some kind of hub, which may be a Zigbee device, then definitely you don't require any SIM. But then there are two types of IoT solutions. One solution is the fixed IoT and the other one is the mobile IoT. Now, what is the difference? In case of fixed IoT, your sensor is just sitting at one single place and not budging from its place. Like for example, you have the smoke sensor, gas leak sensor, door sensor, glass break sensor. There are so many different types of sensors which just don't move from their place, and for such sensor you just require your broadband Wi-Fi connectivity and you can connect to them, or using a hub you can connect to the cloud. What about those sensors which are continuously moving? In this sensors you have no other option but to go for a WAN connectivity, and the WAN connectivities are provided either through the mobile WAN networks, or you have other lightweight WANs like LoRaWAN or Sigfox. So as of now, the telecoms have an added advantage of having a huge customer base, and which is a very good opportunity, and which is a good base to leverage on providing the M2M solutions to the existing customer base as well. So this edge can be you can add to our advantage, and therefore it becomes very easy to provide SIM based solutions for the sensors. So in that case, supposing your sensor is running on NB-IoT or LTM, then it will be definitely having a SIM. And if a device is running on SIM, there are some things which have to be taken care of. Now, these various types of SIMs and what SIM is suitable for a sensor we will cover in the next coming slide. But before moving to that, one small brief on how are the device managed by telecom. So when you have a device which is connected to a telecom company, it can be a mobile, it can be your any kind of like your laptop also connecting to a service provider. So most of the times the device is managed through some protocols which are standard protocols. So your mobile is usually managed through a standard protocol called OMA DM, which sits on top of HTTP. Then you have OMA lightweight M2M, which is specifically designed for sensors. So a mobile company, if it wants to manage your sensor nodes, it will be using some kind of OMA lightweight M2M solution, and this is a standard protocol, and the difference between OMA DM and OMA lightweight M2M is that OMA DM, as you can see, works on the TCP stack and HTTP sitting on top of TCP. Whereas OMA lightweight M2M is running on CoAP, and CoAP sits on top of UDP. So that is the difference, and it is extremely lightweight. So CoAP header is say around I can say that 80% smaller than the header for HTTP. That much is the difference between the two. And then the still lighter weight solution is using MQTT. So you can also do device management just using MQTT protocol, wherein even the device management is also a kind of topic where you publish or subscribe to. Then the heaviest of all protocol is TR69, which is the legacy protocol which was being used and still being used by many telecoms for providing or managing your Wi-Fi broadband subscriptions. So next is the types of SIMs, and you all are very well aware the different types of SIMs that you have. So we used to have this very huge legacy SIM, and which moved over to from mini SIM to micro SIM to nano SIM, and finally we have the MFF2 form factor, which is a very small SIM card. And this is about the virtual the physical SIM card, and then you have the UICC, or the Universal Integrated Service Card, and this card is special in its in the sense that it is just you can call it as a part of the SIM card. So I have tried to differentiate between the two. So you have the SIM card, and this portion you can call it as UICC. And UICC is a combination of hardware and software. And this SIM card now is become a legacy, or is not very much advisable to be used for sensors or IoT devices. So what do we use for sensors? So we go for the eSIM, the embedded SIM, or we go for the EUICC. Now, in case of embedded SIM, that is also a physical kind of entity, but it is soldered. Unlike the regular SIM card, which can be replaced and removed by the customer, which you are also doing, this SIM will be will be hardwired onto the board, soldered onto the board, so that it can't be removed, can't be misused, and cannot be stolen from the devices. And a next step further in eSIM comes the soft SIM. So when you go for soft SIM, even there is no soldering or any physical entity as such available to be soldered onto the board. It is finally moving over to a software based solution. So the entire SIM becomes a soft SIM, and it can be ported onto your device through OTA, over the air services. Now, what is the advantage of eSIM is that it cannot be removed, it can't be misused. It also has a better signal reception, and it can be so this is an interesting thing. It can be configured for change of operators remotely. Like for example, today I am a third party and I am using Telecom X SIM to provide my smart agriculture solution in the field. Now, if I go for the physical SIM, what will happen if I have to switch over to a Telecom Y? Then what do I have to do? I will have to physically go to visit each and every field and actually go and change the SIM, which is not at all a feasible solution. So the better option will be the eSIM, and it can be configured for change of operators remotely. Now, what is the advantage of eSIM is that it cannot be removed, it can't be misused. It also has a better signal reception, and it can be configured for change of operators remotely. So the better option will be the eSIM, and it can be configured for change of operators remotely. And ingress protection easiness, why I am trying to say here is, then when the SIM card is soldered and hardwired onto the board and the entire enclosure is perfectly sealed, a very important part of sensors is ingress protection, or the waterproofing and the dust protection part, which is much easier to achieve. And it is very important for some sensors, like if you go for fuel sensors or if you go for agriculture sensor, they have to be weatherproof. So you cannot afford to provide additional slots or additional holes, things like that, for inserting SIM cards, or even the connectivity to power supply is limited for such type of sensors, and you have to take great care in providing the ingress protection. That is a part of field deployment challenges, which maybe we can discuss in another talk next time. And as I discussed earlier, the main protocols which should be used for connecting the sensors are MQTT and CoAP. I have just given HTTP also, but HTTP is not that much preferred protocol when it comes to the sensor. And as I said, every sensor must have the particular client running on it. So sensor is a lightweight device. It is not like a regular laptop or a PowerEdge device wherein you can port every possible kind of network stack. So definitely it has to have a limited amount of stacks. So we have to pick and choose so that the sensor remains a lightweight device. And there are some popular, I just wanted to list out the popular RTOSs used while engineering for sensors. And some popular RTOSs are here in front of you. So free RTOS is the name of the RTOS. It's not like any like random free RTOS is also an RTOS. And the popular sensor chips, I apologize, I may have left out. There are quite a lot of very good chip vendors for sensors, and some I have listed out here. A sensor is a combination of all these things. An RTOS should be present in the sensor. There should be some sensory part, which is the chip. Then there should be a radio part, which can be from so many vendors that I have listed, or the no preferable. I like to mention here that a disclaimer that we are not, nothing is our like preferable thing or anything as such. So just try to give some examples over here. That's all was the purpose. And just wanted to list out that nowadays another buzzword is fog, mist, and edge computing, and the difference between the three. So you have the fog computing is usually more focused on any computation which is try to be done at the device level or the sensor level itself. And edge computing, when you are doing some computations at the hub level. And mist computing is basically the edge has two parts. One part is the non-IP part or the gateway part. The other part is the last node on the IP network is also called an edge. So when you perform edge computing on the last node on the IP network, then it is usually sometimes people call that as edge computing, and sometimes the computation happening at the hub can also be called as an edge computing. So next we come to the last few parts of my slide, which I just wanted to throw light on how the IoT adoption is going to happen in future. And this is the latest January 2020 survey, where it was predicted that 93% of enterprises will adopt IoT technology, 80% of industrial manufacturing will adopt IoT technology, 90% of cars will be connected to web through IoT technology, and 3.5 billion cellular IoT connections will be installed. And during 2020 itself, the global spending on IoT will reach around $1.29 trillion. It's not rupees, it's dollars. And by 2021, the industrial IoT market size will reach $124 billion. And by 2024, it will reach $14 billion, and 2026, it reaches 1.1 trillion. As I told you all in the beginning of the slide, if everything goes well, maybe I will we can just review this slide when we again in 2024 and again in 2026. May the vision summit continue for as long as many years to come. And with that, just one small idea of how important is your smartphone with the sensors. So your mobile phone, it may be scary and it may be good to know also, because if something happens to you, a lot of people will come to know about you. and that something has happened because there is a lot of tracking happening. A lot of people are interested in you. Your mobile phone can have many sensors which you don't even know what all they are talking about you and telling about you to the cloud, your physical activities, your movement through location tracking, even the way you are holding your phone. And one good thing, any false or accidents also can be known. And of course, many of us might be using this feed of your walking, running. In fact, voluntarily, we are participating and we are telling that, okay, take my data, analyze it, give me back the results. And you are doing that every single day. When you click on I agree button, you are agreeing to so many things which you really don't know what all, how valuable it is for, maybe not for you. So maybe you are not interested in yourself so much as rest of the world. And it's a happy thing, good thing to know. People are noticing you. And then finally, last, I wind up my talk with this food for thought. So, telecom, of course, telecom has brought the world closer. We could not have imagined battling this pandemic without a telecom. Maybe every single moment of your life that you are living, you need the help of a telecom. So maybe, and one thing that despite the pandemic, continuously 24/7, the network service we have our network planning team and deployment team which has been relentlessly working without fail to give you continuous connectivity, and it takes a hell of a lot of effort to do that. So maybe we can take out sometimes a moment to thank your telecom service operator, whoever it is. I'm not talking about like only Jio, but your service operator. They are really putting in a lot of hard work and lot of efforts to make things happen for you day in and day out. And one last thought for the day, that of course now we are living in a global village. You remember in olden times when we used to step out, or when we are doing something non-conventional, or when we are doing something antisocial or unlawful, in a small village it will not happen because we will always think that, oh, people are watching us, we cannot do this. And then came that in between time of non-answerability, and maybe things went haywire, maybe crimes also increased during that period. But again, thanks to the great connectivity and the services that are present today, again we have come back to that thinking of global village. No, wait, we can't do this, people are watching. So again we have come back to that domain of answerability, of um, uh, following lawful guidelines, and taking care that okay, people are watching us. So you can see the crimes are reducing, and in fact 80% of crimes are getting solved through surveillance. So this has become a very good boon to us. But at the same time, I again put a question mark. Technology is a boon or bane. I leave it on you to think about it. To 5G or not to 5G, because there are things which are there, like millimeter wave connectivity. Do we really require it? Do we really, what is the health effects of those things? So definitely we have to weigh the pros and cons, and finally come on very very thoughtfully, narrow down and converge on something which is very good, for more efficient, but at the same time it is also good for our health. So with this, I'll wind up my talk and I will open the session for questions. Thank you so much.
Thank you, Ms. Pandey, for exciting presentation. Yeah, I completely agree with you that today, wherever we go, the network is following us, and without the network, we are handicapped. And thanks to all these networks, today we are running this conference also virtually. So we are quite behind on time. I know there are a lot of questions lined up already, Soma, but unfortunately, for interest of time, we'll move ahead and we'll discuss, connect with all the audience who are having question with you so that you can answer offline. So let's give a big round of applause to Soma for this exciting presentation on communication. Thank you so much. So moving on.